Good afternoon. I think everyone had a lunch. It's already afternoon. Myself, Sharan Bujruke. I have around 18 years of experience in data and analytical space. I'm currently working as a principal data integration lead for Discover. So today I will be presenting on config-driven development framework architecture in DataOps. So you may have heard configuration management in DevOps. So today what I'm going to go through here is data management pipelines, how we can automate them, and how we can use the architecture of config-driven development to build the data pipelines. So as part of this presentation, we'll go through the traditional approach of development, how we usually go through that, and what is config-driven development, and why should we have to adopt them in building data pipelines, and what is the different solution capability of CDD, and difference between the traditional and modernized CDD approach while building data management pipelines, and some of the use cases which I built over the years in last couple of years. So as we know, the building data integration pipelines in today is a very challenging pursuit. Like we have shifting requirements. Even after the project completion, we may find ourselves following long tail of software development life cycles, which usually involves complex updates. One of the reasons this happens because we have built traditionally the same way of development. Like take an example of a house or a bridge, right? We go through basement, then pillars, then we build a bricks, then roof. So it's like similarly like bridge, but as we get modernized, so now we have built the components, and then we are combining each other in the building house also, in the bridge also. So what I'm trying to cover in this while building data pipelines, so what if we can build application which could easily adopt, and just a few changes in the configurations, we can migrate to productions. And what if we can build applications which are dynamically composed and execute through pipelines just for our configurations, and which can reduce development hours significantly, and also the cost. So let me go through what is config-driven development. CDD is a different way of building data integration pipelines. So it's a simplified low-code, no-code framework architecture that enables configuration workflows, execute generic ETL and ELT frameworks for different requirements. It can be implemented on-prem or on cloud also. So it's a powerful tool to promote reusability and rapid development when employed correctly for the appropriate problem space. Yeah. So how do we build that? So as you see in the diagram, it's a tool-agnostic modular design solutions. So when we build config-driven development, we can build a framework which are different components and execute the pipelines through the configuration. So that way, irrespective of any tool, we can approach this architecture through config-driven development. And it's easily configurable. So any changes you want to do on existing code, or any changes you want to build a new, or you want to bring a new ETL initiatives, so you can just configure it whatever you want, using a plug-and-play artifacts. So you use it like for example, you want to ingest a new pipeline. So you just mention what is my input, like what is my data source, what is my input. So these all things can be configurable. Once it is configured, it's just a plug-and-play, and it can run the whole framework by just configuring any integration or data ingestion pipelines. And along with that, so you have all the metadata in configuration. It can be a JSON file, or it can be a database tables. So you can build a SLA reports, you can build a metadata reports out of it, you can build a whole data governance out of it. because you have complete metadata in database where what is the source, what is the target, what kind of transformation you are applying, what kind of data quality you are applying, what kind of data movement controls you are applying. So those all things are available. So using those things, you can build a different dashboards out of metadata in config-driven development framework architecture. So these are the different modular CDD solution when we are building a framework which need to be considered in config-driven development. So as we know, the independent components are built first and starting at atomic level, and then we will build an interface using the config-driven portal. So we can use a portal UI UX layer with a database or JSON file. Then you enter all the configurations which execute those pipelines by just one click. So the different pipelines which can be built is the data integration pipeline to adopt any business rules dynamically and apply data movement controls. As we see that, right, in any traditional development when we go through, how many of you guys have faced like, how does the traditional development goes? Like, we create the business requirement comes, and then we create a story out of it. Then developers start working on addressing those business requirements. So if there are multiple developers, every developer, even though there is a similar kind of business requirement, when you want to build a similar design, but every developer address those business requirements in a different way. So every developer develop his own way. Some people just address those business requirements. Some people not only address business requirements, they build a lot of data movement controls like restartability, error handling. So those designs are adopted again in individual developers. How do they work on that? So we see like when we go into the code review and we see like, oh man, this kind of approach is already there. There is a generic processes there. Why you have developed again? So we see a lot of inconsistency when we go with the traditional approach of development. But this one, when we go with a CDD solution, what we can do is we build a framework out of it. And when the requirement comes, these are the questions like, for example, any data movement controls, like if you see data quality design principles which we follow, the accuracy of a file, whether the data which we are receiving is a complete or is it a consistent data. So those all requirements will be addressed when we are building a framework. So all the data movement controls, like, is it a duplicate file? So how do we process it? If file didn't come, what should we do the action point? So these all questions were never, most of the times not asked. And those are like when we productionize it, when we start facing it, then people start addressing those things. So what if these all are built in separate component and run the pipeline and execute this whole pipeline, like whenever like you want to ingest a data ingestion file or when you want to build a data integration business rules. So you have a set of data quality rules, set of data movement controls, which needs to be defined. Like you just ask business people or who are defining the requirement, you just ask them, okay, these are my, as part of this framework, when I want to ingest a new file or when I want to build a new pipeline, these are set of questions which we have to flag it out, yes or no kind of thing. If it is yes, like I want to make sure that if duplicate file is there, how do I process it? So should I fail the whole process or should I need to send a notification to business saying that, okay, we received the same data. So please look into the source or we should contact a source. So those all set of rules can be pre-written in a framework. And once it is written, so you execute like whenever you get a new ingestion of file or whenever you want to build a new ETL data integration or ELT, so just you go and enable those features for that particular pipeline. So that can be done. And along with that, we do have you can build a data quality at motions, right? Like we have so many data quality rules. Like whenever we're defining the business rules of data ingestion or data integration, we never ask such questions, okay, each field level, we never go and ask like, what should we do if this comes null? Is it like, especially SSN, if it comes null, well, what should we do? Or date of birth, if it comes null, what should we do on this? Should we reject the record? Should we just still load it with a notification sending this kind of a consumer ID, doesn't have a date of birth information, so reach out to source kind of thing, right? So those all information can be pre-built in a in a CDD solution where it is individual components are built, individual generic processes are built, and once they are built, we combine them through config data layer through UI UX. So we can build a UI UX for that config data model. So every requirement has a different, of course, when you are building data pipeline, most of the data pipeline can be built with config-driven development. Of course, there will be some exceptional cases are there. We have to see how to address that. But I have built like data ingestion, data integration pipelines, test validation frameworks, and reporting frameworks, batch reporting frameworks, using the CDD solution. So CDD architecture, these all are built. So I will go through them when we go through the use cases. So what is the difference between traditional versus modernized CDD approach? As we see, it's a low-cost value. Whatever we spend while developing a framework. Once the framework is developed, either it's ingesting a new file, either it's testing a whole new ETL or ELT, or it's building up some business rules. So everything is config-driven there. So the whole development is going just while building the framework. Once the framework has been built, you are no more building any developments. It's more on configuration. You just go and add those rules, what is required for those data pipeline, that data integration pipeline, then you are done. So it goes years together. Like, it's a very low cost value. It saves up to 60% of time and 40% of development cost when we go through CDD approach. Whereas in traditional approach, it's a very high cost value. There is a planning is required. There is hiring, deployment process, high development and maintenance cost. Whenever small changes there, you have to go through all the deployment cycle. Like, you just develop all the existing development, and which is prone to defects. Like, so many developers are working on that, and it's always prone to defects. There is always a development challenges are there when we go through traditional approach, as I said earlier. So 15 developers are working on similar kind of requirement, but all 15 develop in the different ETLs or ELT, data integration applications, data pipelines. And if you go into reviews, most of them can be just built by generic process. And that generic process can be parameterized or configured, and you can just run through the pipeline. But when we assign the stories for a pipeline, to build those data pipelines, every developer work on their own speed, and they work on their own style of development and design. So it always reach out to more development time, and it is result into missing a lot of non-functional requirements, and which result into high maintenance cost. So when it goes into production, UC start telling, oh man, this file came as empty, so what should we do now? Well, then we again go back to the development, again fix it, then again it goes to testing. So it's a lot of deployment challenges will be there. And again, any job failure happens, there is so much of troubleshooting for any data pipeline. Whereas here you have everything in the config-driven. So whatever issue is there, you just fire one query and you will get what exactly issue is there for that particular ETL or ELT data pipeline, right? So there is always a performance issue. Each developer develop the data pipeline in their own speed, and they create on their own design. When they does that, it's always some of them end resulting into inefficient workflows management layer, and there will be a lot of impact analysis which cause issues, and it's a slow development happens. Performance issue will happen because everyone will not take care of that. So with this one, when we are building the independent components together, we look for all the things as a CDD framework, like data movement controls, restartability, how to do error handling, what are the notifications we need to send to business, and it for different pipelines also, right? Data ingestion, data integration, inbound, outbound, all those things will be covered in this. So once it is done, so you are just configuring it for each new requirement and run the pipelines through the config-driven development. So some of the use cases which I have implemented, I worked with the team to implement in recent days is, which why I can explain. One of them is test validation framework, which like one of the use cases which in my one of the migration program which I was working 1 year back. So it was like there were around 300 data pipelines were there, and after 1 year also they were able to migrate only 20 to 30 data pipelines. Like when I joined that program, I said like, why is it taking delays? So they said that we don't have a resource, we don't have a testing resource. So, so the time of testing resource and business resources is very less, and that's why it is taking time, because so many initiatives are running. This is one of the initiatives, and being this is a mostly technical-driven project, it is, right? So migration is a more kind of technical-driven. It's not a business initiative. So because of old tools are not getting support, we are implementing with the new tools. So what happens at that time? So I brought out with a CDD workflow saying that you have a migration. So you are migrating from old ETL to new ETL, or old tool to new tool. So what are you doing? It's the business functionality remains same. It doesn't change anything. So we just need to compare what is your expected output versus actual output. So if everything is matching, then you are good. You don't need someone to validate everything. So you run for multiple days to look into that. If everything is matching, then you should be good. So we built a framework, complete validation framework, which says that it's just one single table we built. Like we can build a whole data model out of it, but we built just 1 or 2 tables out of it, where we say that, okay, what is it? It contains all the requirements to execute one simple validation. So it says what is your expected output, where the expected output resides. Is it a database? Is it a file system? Is it XML? Is it everything? So you mention those all things, and what are the keys to compare between those expected output versus actual output. So if you see the diagram, right, you can see that, so the enter configuration through the portal, so which goes to database, where like all the requirements are there. You just mention that this is my expected output, this is present in this, it's in database, or is it in this file system, and these are the keys to compare it. These are the keys you should not compare when you are validating the results. So once it is done, your frameworks take the config, right? It reads the config, and it gets all the information, right? Expected output, all the file path, database information, all the layout, everything, and similarly the actual output. Once it is done, so your framework runs through that, and so you can configure to from 1 to 100 ETLs there. So once you just execute the framework, it will compare all the results and create a Excel sheet out of it and send it to your mailer directly. It gives details about, okay, this is my expected output, this is my actual output. And out of this, these many records has differences. And out of these records, it goes to at that level, which field has what differences. So we created this framework, and believe me, within 8 to 10 months, we completed 200 ETL of validations. And all the validations are done and migrated within 1 year. Everything is completed. So that's one of the fastest validation we have done in recent time. Like even though like just for 20 ETL, it took for 1.5 years, for 200 ETL, we finished in 8 to 10 months. So that's one of the use case which I relate to recent time. And similarly, we have implemented data lake framework in my previous experiences, where like, as I said, you entered, you have a portal built, and that portal is not only to give input, what is for my data ingestion or data integration pipeline. It also has, portal also has information to the users to create dashboards out of it, right? It has reports, you can create reports. You can get up to what level we have built the framework is for a data ingestion and data integration. For every step, it does how many records are read, how many records are ingested, right? How many records are read, how many records are joined and loaded into this one. So it does all the data reconciliation also. Once it does, so and all the metadata rules. So you execute the pipeline. Like for example, you might have a requirement, okay, I got one data set which need to be inserted, and then it has to be joined, or then it has to be looked up for a couple of records on the consumer IDs, then you load into the target, you confirm the data, then you curate the data. Those all requirements were there. So when we designed that particular data set end-to-end, we said that, okay, the first step of this one is ingest this pipeline. So you have to ingest this particular file into data lake. Once you ingest it, you have to join for multiple data sets to confirm the data. That's more kind of a data integration pipeline. So even those things, right, the people always ask, can we do data integration pipelines through config-driven? Because data ingestion is easy because there is no business rules are involved. But when we go through data integration, there are a lot of business rules are involved. And when we started business rules, so you can build a data model in such a way that it covers most of the business rules, transformation where you can define them through config-driven. But there are multiple approaches to achieve this. Like either you can build a complete business rule mapping tables, metadata table, where you can mention those all things. Or what you can do is you step off SQLs, right? Now ELT is famous with a lot of performance and everything. We can use ELT where like you just mention, okay, the first step is execute this SQL. The second step is update this one. Then third step is insert these records. So you go by step, and you mention that what is my step, first step has to be performed for that particular data pipeline. So once it is done, so you can achieve all those things. The metadata rules, DQ rules you can define, data movement controls define for ingestion to integration pipeline to confirm and curate the data. So these all things we did for multiple clients in my prior experiences. And it runs like hell, it runs very fast. And it's like, because with the ELT, so many things are coming now in terms of faster processing. So everything is achieved through config-driven development. And with this, there is one more use case which I want to cover is batch report framework, right? So this is like, again, recently we implemented where like there were a lot of batch issues are coming when they started implementing. So there were files, because the data pipelines were already built. So I said, like, it's already built. We cannot change everything now, because if we want to migrate everything to config-driven development, it will take hell out of time. So how do we achieve some of the batch issues? So we built a framework saying that if anything comes like empty file or duplicate file, it starts sending notification before the batch processing or fail that. And it gives a complete batch summary and SLA report. It gives like what has been done for empty file. If we send some empty file, empty data sets to some consumers or vendors, it immediately says that, okay, these are the files which are created empty, so what should be done? Should we need to send or not? So that kind of end-to-end batch report framework is built, and we have built a dashboard out of it. So now business can access, okay, one click, they can see that, okay, whether batch is completed, how much is SLA has met, how many how many jobs has missed SLAs, and I can see they can directly see how many data sets which we sent to the vendors are empty. Like, is it normal? Like, it also has some of the use cases, right, where we see that, okay, we usually receive a data of, assume that 100 to 1,000 records, right? And suddenly, your inbound increased to million. So what should you do at that time? So your job will run perfectly fine. But when it runs, you know that, like, okay, there is something wrong with the data, and you end up fixing everything. So with this one, we have adopted in such a way that it says, okay, this kind of file comes, it checks the checksum with the previous data. If there is a duplicate file, it doesn't even run the jobs. So those kind of controls has been implemented in the batch report framework, and with this, the dashboards are bar charts, pie charts, every charts are built for business to see that on SLA-wise, batch summary-wise, file summary-wise. So those all things are done through batch report framework. So overall, with the CDD architecture, what we can do is we can build all the data ingestion, data integration pipeline. Even we can build a test validation framework which can be utilized for testing purpose and validation purpose. So, end of the day, what I want to say is adopt CDD for reliable and reusable architecture, rapid development with less risk, and it's a low-code, no-code features. So for any changes, you just need to enter the config to run the pipeline. You don't need to go through whole of development, and it saves lot of cost and time. But along with that, there are some of the principles which we need to adopt. That like when you are going through config-driven architecture, don't go and directly update in production. So try to do it in development and test it. Even though development time is not there, but you have to go still do the testing. So better do testing and then migrate it. That way, adopting those principles, and always make sure that configuration and code are completely independent. The configuration is a kind of a wrapper script which runs the pipeline, but you should not integrate within the code to make harder for implementation. So this way, the configuration can be just a plug and play. You just insert or update whatever changes you want to do, and run your complete framework or complete data pipeline without any code developed on those things. I think that's all what I wanted to cover on that. Other than that, we have a lot on this cover here. So any questions?